Okay, everybody, we're going to talk through these slides about basic probability, and I'm going to post the slides as well. So what is probability? Here's how you find it. It says we use ratios to show how likely or unlikely an outcome might be. This ratio is called the probability of an event. The probability is expressed as this. It's the number of successful outcomes, the things you want, over the total number of outcomes in your sample space. So you guys have already calculated how many items in a sample space. So it's what you want over all the possible things you could get. Here's our notation. We use P of A. The way we say that is the probability of event A for notation purposes. Because you've calculated probability this way, they can be fractions, decimals, percents, or with colons. Here's an example. If you're spinning this spinner, everything's equally likely on there. So what is the probability of yellow? And here's how you would calculate it. There's one outcome out of 4 possible outcomes. So fraction form is 1/4. Decimal form is 0.25. Percentage form is 25%. Or colon form is 1 in 4. The way you read that is the probability is 1 in 4. Or 1 out of 4. Okay, because of the way probability is calculated, if you think about this, it's the number of successful outcomes over total outcomes. This number has to be between 0 and 1. Remember, your successful outcomes are a subset of your total sample space. So you've always got a smaller number over a larger number. So, or at most the same number over itself. So you can have a probability between 0 and 1. So if you calculate something and you get a probability of 5/3, you have done something wrong. This isn't a language lesson or an English language lesson. I couldn't find a good graphic of this, so I copied this off the internet, but it does what we need it to. I want you to consider these words and how they relate to probability. If something has a probability of 0, it is impossible. If something has a probability of 1, it is certain. It has to happen. And then if something has a probability of 1/2, it is equally likely to happen. Okay, anything below 1/2 is considered unlikely or less likely or not very likely. Anything up here in the middle range above equal is likely or more likely, and so forth. So those are some words you might see associated with some of these things. Okay, let's try some examples. Here's a bag of marbles. There are red marbles and white marbles, and then they're numbered 1 through 9. Some of the numbers repeat. It's not all 1 through 9. So there are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marbles in this bag. It's always good to know the number of marbles in our sample space because that's our denominator. Okay, so let's read this. This says the probability of red is 4 out of 10. Okay, because there are 1, 2, 3, 4 out of 10 marbles that are red. Now, you can reduce that. You can reduce that to 2/5. And a lot of times when you do online activities to test you, it will have reduced it. I'll be honest. I always leave probabilities like this while I'm taking notes and practicing. I even had kids leave it like that on exams so I could tell where their numbers came from. So I'm going to, in my notes, leave it like this, but recognize when you do a quizzes, it might very well expect you to reduce 4/10 to 2/5. Okay, this is the probability of white, which is 1, 2, 3, 4, 5, 6 out of 10. Think about this. What's the probability of reaching in that bag and picking a red or a white marble? Well, there are only red or white marbles in here. There are 10 ways that that can happen out of a 10 possible outcomes. So that is 1. That has to happen. It is a certainty that when you reach in that bag, you're going to pick a red or a white marble. Let's look at some more. Here's the probability of picking a 4. There are actually 2 4s in this bag, so it's 2 out of 10. Consider the probability of red. There's 1, 2, 3, 4 in this bag, 4 out of 10. Think about this. What is the probability that when you pick one marble, you get a 4 that is red? It has to be a 4 and a red marble. Well, let's see where that is. This is a red 4. There's only one of those, so that's 1/10. consider this wording. What's the probability you pick a 4 or a red marble? So you have 1, 2, 3, 4 red marbles, and you have this number 4. That would be okay to get that. That's success. So you have actually 5 marbles in this that would give you success, a 4 or a red. Please notice you don't count this one twice. So you have 5 out of 10 for your probability. Let's try this. Again, the probability of 4 is 2 out of 10. What's the probability of getting an odd marble? Well, there's 1, 2, 3, 4, 5 of those. Did I miscount? 1, 2, 3, 4, 5. This should say 5 out of 10. Okay, so what's the probability that you get a 4 and an odd? Okay, the marble you pick is 4 and odd. Well, look and see in here. Is there a 4 and odd marble? No, there are none of those. Those two things can't happen because 4 is not an odd number. Here's a new vocabulary word. These events are mutually exclusive. Being 4 and being odd are mutually exclusive. You can't be both. Let's try this, 4 or odd. Okay, so there's 2 4s in here, and then 1, 2, 3, 4, 5. So 5, so 6, 7. 7 out of 10 ways to get a 4 or an odd. I managed to add that up correctly. This should be a 5. All right, I'm going to put some on the screen for you to try. Pardon me. And here are the answers to those. This is easy enough. An even, red, even and red, even or red. Okay, check this out. This is less than or equal to 4. So think what that number, that's anything that's a 1, 2, 3, or 4. So how many of those are there? 1, 2, 3, 4, 5 of those. So 5 out of 10. Probability of white, there's 6 of those. And now you can look for the overlap and the or. So what if it's less than or equal to 4 and it's white? So how many marbles are that situation? Here's one, and here's one, and here's one. Those are numbers. 1, 2, and 4 are less than or equal to 4 and white. So there's 3 out of 10 of those. But what if I said less than or equal to 4 or white? Well, there's 6 white marbles, so we've already got those. Now the numbers less than or equal to 4 are 3 and 4 here, so there's 2 more, 8 out of 10 total. Here's another set you can try. Probability less than 3, so that's 1 and 2 here. Probability of red, there's 4 out of 10 of those. Now let's look at less than or equal to, less than 3 and red. Are there any that are less than 3 and red? The answer is no. Those things happen to be mutually exclusive in this bag of marbles. Doesn't happen. 0. What about less than 3 or red? So there's 4 red ones, and then less than 3, there's 2 more. So that's 6 out of 10. That could be that. Okay, let's talk about some examples with dice. This is the sample space for rolling 2 dice. Think about this. Rolling 2 dice is still a single event, okay? Because you're rolling them at the same time. It's not like you're rolling a dice, waiting, and then rolling a second time. All right, 2 dice are rolled. What is the probability that a 3 is rolled? One thing you can do is cross off, or well, you can circle all the things where a 3 is involved. So this whole row here, there's 6 of these, that involves rolling a 3. And this whole row here, there's 3s involved there, and there's 6 more. But let's be careful here. There's 6, there are 6, but careful now. Are there 12 out of 36 ways to roll a 3? We don't want to count this guy twice. It's actually 11 out of 36. There's 11 different things here in this group of 36 where a 3 gets rolled. Okay, so you can't count those doubles twice. Careful of that, please. Okay. 2 die are rolled. What's the probability that an even number is rolled on both dice? So that would be like 2, 2, and 4 and 2, and 6 and 2. This one, they cross out everything where odds are rolled. So there, where you rolled a 1, cross out that whole column. A 3, cross out that column. A 5, cross out that column. And then you can cross out the rows. And it leaves you with 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes that are successes for you. 9 out of 36 or 1/4. What about 2 dice are rolled? What's the probability a sum of 7 is rolled? That happens along this diagonal here. 7, 7, 7, 7, 7, 7. There are 6 different ways a sum of 7 is rolled. And you do distinguish between 6, 1 and 1, 6 because this is your sample space. Okay, trust your sample space, trust what you're looking at there. All right, how does the word not work with probability? Not means the complement of an event. It means the probability of getting everything but that event. For example, when rolling a dice, what is the probability of not a 5? Okay, so what's the probability of getting a 1, a 2, a 3, a 4, or a 6? Or when rolling a dice, let's see, do these come up one at a time? Yeah, so 5 out of 6. When rolling a dice, what's the probability it's not even? Well, there's 3 numbers on dice that are not even. Okay, they're odd, 1, 3, and 5, so it's 3 out of 6. When rolling a dice, what's the probability it's not less than 3? So not less than 3 is the numbers 3, 4, 5, 6. Okay, you could, like I said, you can obviously simplify those if you want. So here's some that you're going to try. Given a bag of marbles with 3 green, 2 yellow, 5 red, what's the probability of not getting green? So here's your bag of marbles, and these little circles are your marbles. Here's your green ones. There are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marbles here. So not green would be these 7. 7 out of 10. This is how you can write complements. If you're saying A is your event, you can write A prime or A with a bar over it. I usually see A prime. The way you read that is not A prime, but A complement. And it's everything not in set A. Okay? So if you have this set of cards with letters, what is A complement? Well, it's everything that's not an A. It's U, E, R, Q, H, C, H, L. Okay? Everything that's not an A would be an event that you're looking for there. Okay, we're going to try some problems with marbles. What's the probability of pulling a blue marble? What is the probability of purple marble? And I'm going to start to smear over to using this notation. So start to recognize it. Hey, these are blue, red, green, and black. So what's the probability of getting a purple? And lastly, what is the probability it's not red? 7 out of 12. So here are your reds. You have 1, 2, 3, 4, 5, 6, 7 things that are not red. So it's 7 out of 12. Okay, geometric probability. What's the probability of landing in the area of the black square if shooting an arrow? So what you have to do is take, this area divided by this area. That's how you calculate it. So the big square is 36, the small square is 16, so the probability is 4/9. Here's one for you to try. So there's 2 types of probability. There's what's called theoretical. It's what should happen. For instance, the probability of getting a red out of this is 1, 2, 3, 4, 5, 6, 1, 6. However, if you actually do this over and over and over again, you're going to get varied results. And you might find out, like let's say you draw this 30 times, they found out that the probability of a red was 0.27. That's experimental probability. We're working with theoretical based on calculations. Experimental is what actually happens in a lab. Okay, that's everything. You have an assignment probably to do some sort of practice after this. Thank you.